This is a very sneaky question because when we see the word depreciate, we usually think about exponential growth and decay. It's just a word that's very tightly associated with exponentials. However, this question also says other words that are much more tightly associated with linear equations. So if we look here, the value of the car depreciates at a constant rate. That's key. That's code for lines at 10% of its initial cost each year, and there's really where they sell it, right? It's not that it's losing 10% of its current value each year. It's always losing the same amount, 10% of whatever the initial value was. So in this case, that would be $2,450. So it's a constant loss. So whatever the case in real life, okay, this particular story is telling us that we need a linear equation. So it's really just going to be A or B, and hopefully you can see, okay, if it's losing 10%, I need to incorporate that in here somehow. That means choice B, because it's not losing $10. That's what choice A would be saying. And if we wanted to, we could test these answer choices out by making points, right? We know that one of the points is going to be 0 to 24,500, so that's the initial value, and that's going to work, I think, for all of the choices. So that's going to lead us into the next point, and here's where we have to understand the question anyway, right? We need to be able to take that 24,500 and subtract 2,450, and I'm using a calculator, I'm cheating a little bit, but that's just for the sake of time, and so we would have a kind of weird point like this. And so this would not be a good way to do it if we had the no calculator section, but it is valid if you really need to check your work. It still would not get us down to the one right answer because the exponential is still in play until we get to 2 years, but that just goes to show this is much more about understanding the story and those code words that they're using and not falling for the trap of just assuming that depreciation is always going to be exponential. Sometimes it's linear. You got to look for the code words.